Have you ever wondered why the formulas for the area and the circumference of a circle have been known to mathematics for so long, even in the era of the ancient Greeks? When the Greeks were searching for the area of a circle, what they were actually doing is a form of calculus. Now, the Greeks knew this equation displayed on the screen now, that c equals 2 pi on r. They had done some experimentation with circles, and they found that always, when you take a circle and you measure its circumference, the ratio between the circumference of a circle and its radius is always this number 2 pi. But how did they find the area of a circle? A circle is a curved shape, and the Greeks had no way of dealing with that until Pythagoras came and found a solution for how to find the area of a circle. Now, Pythagoras' idea was to split the circle into different little subsections and sum the area of those subsections to get to the whole. Let's see how he did this. I will redraw my circle out just here. Now, his first idea was to split the circle into 4 different quarter circles, which I will draw now. So we have here circle 1, or area 1 rather, area 2, area 3, and area 4. Now if we add up all these areas, we get back to the circle. So let's give that a try. What we're going to do is take these pieces apart and put them back together. So we are going to draw them out like this. We're going to have one here, roughly quarter circle. We're going to have the next one here. Oops. Next one like this. We're going to have the next one like this. We're going to have the last one like this. And I will rewrite our areas, A1, A2, A3, and A4. Now all we've done is simply rearrange these pieces to a form that looks closer to a rectangle. So let's assume for a moment that this shape was a rectangle. Then we would have a side length of r, because each of these quarter sections has a side length of r. Now for the flat bits on the bottom, we know these from the circumference formula. Okay, so we know that if the circumference of the whole circle is 2 pi times r, then that means that the circumference of a quarter circle is going to be given by 2 pi r over 4, or in other words, half pi r. So these side lengths, now that we have 2 of them, is going to be twice that. So it is going to be pi r. Now we know how to take the area of a circle. We are going to simply multiply these 2 things together. Pi r times r gives us pi r squared. But hang on a second, because this area is not even close to a rectangle. First of all, it has a diagonal edge, and second of all, the straight sections of the circumference aren't exactly straight at all. They are parts of a circle. So let's do the same process, but divide the circle up into even smaller pieces. So this time we shall consider dividing the circle into 8 pieces. So we're going to go 1, half of that, half of that. Oh, that was terrible. That, and that. Now here we've got A1, A2, A3, all the way up to A8. And all of these again have a side length of r, the radius of the circle. Now let's put these pieces back together. We're going to have 1, 2, 3, 4, 5, 6, 7, and 8. Now again, these pieces all have a side length of r, because that is the radius. Now, if we've split the circumference into 8 pieces, then we're going to be given by 2 pi r over 8, same thing as 1/4 pi r. And since we have 1, 2, 3, 4 of them on each side, this is again going to be given by pi r. Now, we can generalize this process into n different pieces. If we cut the circle into however many pieces we liked, we would have this, this, where the pieces are becoming thinner and thinner each step. Notice how this shape approximates much more closely the shape of a rectangle. If we have n pieces, then the circumference of each piece is going to be 2 pi r over n, or 2 over n pi r. Given that we have half of n on each side, we're going to get pi r here again, and r here again, for whatever n we choose. As we make n increasingly big, eventually up to infinity, we're going to find that the area of our circle approximates exactly what we expect, pi r squared. Now, this process of taking little pieces, dividing an area of a curved shape up into little pieces that we can manage more easily, and summing them all up, is the essence of integration and calculus. Now, for the particularly astute calculus students, you may have noticed a relationship between these two formulas. Notice that if we take the derivative of our area formula, then we end up with the formula of our circumference, 2 pi r. Why is this the case? Let's have a look at another example as to why. We know that the derivative of a function is simply the limit as h goes to 0 of its function plus h, the tiny increment, minus the function divided all by h. What does this mean in terms of our circle area? Let's draw out our circle again. Now, we know that this circle has a radius of r. Now, when we evaluate our area just of this circle, we are going to find that the area is, of course, pi r squared. Now, what happens when we add some tiny increment h to the area of the circle? In this case, h is going to correspond to a slight increase in the radius. I'll mark this here as h. Now, I will draw another circle around there. What's the area of this new shape? The area of this new shape is going to be given by pi times r plus h all squared. Now, notice what happens as we make h smaller and smaller and smaller and smaller. This area here, that is the leftovers in between the circle and the parts that are covered by h, is going to shrink to 0, all the way until the added area simply represents adding another tiny layer to our circumference. This is why, when we take the derivative of the area function, we are going to end up with exactly the circumference. That is the little tiny piece that we're adding onto the area of the circle each time we increase h by an infinitely small amount. I hope this has clarified some of the concepts of calculus and given you an example as to where it has been used as maths has evolved over the centuries. Thank you for watching. My name is Henry, part of a team at Elucidate, a non-profit organisation that helps young people succeed at school. If you would like to see more chemistry videos, click up here. If you would like to learn more about us or support us, click down here.